Okay, so we are back on page 287, which says constant functions, Definition, if f of x is equal to c, where c is a constant on the interval between a and b, then we get this. So if I have the function is c, y is equal to c, nothing but a straight line, right? It's a constant. From a to b, the area under the curve is obviously going to be b minus a, this length times the height, right? That's all that's saying right there, okay? Is c times b minus a, okay? So example number 3, ship sails steady at 7.5 nautical miles per hour from 7 to 9. Express the total distance traveled. Well, so now we're going to have this 7.5, and we're going from 7 to 9. If I wanted to express this using the integral symbols, it would be from integral from 7 to 9, where the constant is 7.5 d of x. So it's going to be 7.5 times 2, 15 nautical miles, right? Okay, so that's that. Flip the page. Definite integral as an accumulator function. Okay, this is fairly important to know. Okay, so accumulator function. Green box there says the accumulator function. Accumulator function a of x is equal to, from a to x, f of t dt. Is that what it says? Yes, it is. Okay, so what this is that you have a function that looks like this. You're going from a to x, right? And you're going to do the area under the curve. And the reason why it's called the accumulator function is because as x goes on and on and on, you're accumulating more area, right? Okay, does that make sense? You're amassing more, you have more area under the curve. That's why it's called an accumulator function. Okay? Example number 4. So let's see if we can do this. An accumulator function. Let f of t be equal to 1 plus 2t for 1 to 6. Write the accumulator function a of x as a polynomial where, okay, so in this one we have and we're going to go, what's the function? 1 plus 2t. So we're going to get 1, and then we're going to start from 3 to 6, is it? Or is it what? Yeah. 2 to 6?
Yeah, 6.
1 to 6, right? 1 to 6. Okay. So the accumulated function is going to go 1 to, you notice it's not 6, right? 6 is what? 6 is nothing more than the upper bound of as far as high as x can go, right? Okay, so we're going to do x. Then we're going to go 1 plus 2t dt. Okay, so let's see if we can actually do this, how we can calculate this. So if we, let's call this guy x. So I need the area underneath here, right? This area right here. What is that? What is that called? It's a trapezoid, right? It's a trapezoid. Your favorite shape.
No.
The trapezoid. So the area is what? From 1 to x, right?
Excellent.
So it's x minus 1. That's the base. The first leg is when t is equal to 1. What is this value? 3, right? 3. So the first leg is going to be 3. The second leg is going to x. So it's going to be plus 1 plus 2x. You're going to divide this by 2. That make sense? Okay. So we're going to get 4 plus 2x. And you have 2 here, so it's going to be 2 plus x. 4 plus 2x divided by 2 is 2 plus x. Or rewrite this to x plus 2. So the function itself is going to be x squared plus x minus 2. That's going to be your answer. Okay. So just keep in mind the actual concept of accumulator function. Okay, we will use that very heavily when we talk about the fundamental theorem of calculus. Okay, integrals on a calculator. Your calculator will do integrals for you.
Great.
Okay.
We didn't even need to learn this.
So let's go to example number 5. Okay, we're going to use NINT, N-I-N-T. I think you guys, it comes out as F-N-I-N-T. Do you have a function called F-N-I-N-T there? Looking in your math or programs or F-N-I-N-T, F-N-I-N-T. Okay, so let's see if we can find, using F-N-I-N-T, -1 to 2, what was it? X sine of X, X sine of X dx. Can you do that using your calculator? What did you get? What's the value? 2.04, and you are correct. Okay, all right. So let's see if you can do B and C also. I just want to verify that you can actually plug things in your calculator without screwing it up. While you guys are working that, I'm going to go ahead and write down the next problem. Good? Are we good?
Yep.
Everybody familiar with FNINT? There are going to be on the test, there are going to be instructions that are specifically saying, do not use FNINT. Okay. So it's kind of nice. At the very least, what can you do? You can check your answers, right? You can check your answers, see if you did it right. All right? Okay, at the very least. Okay? All right, so discontinuous integrable function. So in this one, let's go and see if we can graph this guy. Okay, so let's see if we can graph the absolute value of x divided by x. When x is greater than 0, what is the absolute value of x? Is it the same as x? Right? So x over x is 1. So when you're greater than 0, it's 1. When x is less than 0, this comes out as negative x, right? So it's negative x divided by x, which is -1, right? And there's open dots there. Why are there open dots? Because you cannot have 0 in the denominator, right? You're not allowed to have 0 in the denominator. And I'm going from -1 to 2. Right? What is this area? -1. -1, right? So this is -1. This area is 2. So your total answer is going to be -1 plus 2. 1, right? Wow, we really need some more brain cells. Okay. All right, we're good. We're done. We're done.
had to compare us to the class last year.
Last year. Who was in the class last year?